Hello, and welcome to the next video for our geometry unit for class. Today we're going to start talking about triangles. This is not the only day we're going to talk about triangles. There's a lot of triangles, a lot of stuff about triangles that we'll need to cover. First, we'll just talk about the classification of triangles. Everything about triangles that we'll be covering is in chapter 10.3 of your textbook. First, a definition. Two structures in geometry are congruent if they have the same measure. Because it is very vague, we can talk about any type of structure that we've already talked about in geometry. For example, if two angles have the same measure, therefore they are congruent, even if they're not in the same position or they're not even on the same plane of existence. Also, if two line segments have the same measurement, they are considered congruent. We can even expand that farther, saying that if two shapes have corresponding parts the same measure, then the shapes themselves are congruent. We will get into congruent triangles later in the semester. The symbol for congruent is an equal sign with little squiggles on top. So that's how you can determine whether they're congruent. Please note that congruency is between structures. And so we don't say the structures are equal to each other, we say the measurements are equal, but the structures themselves are equal. If we look at the diagram here, we can say that angle 3 and angle 2 are congruent because their measurements are exactly the same. Now these measurements are the same because we've discarded that from vertical angles. We also know that angle 6 is congruent to angle 3 because their measurements are the same. We discovered this when we talked about alternate interior angles in class. So what is a triangle? A triangle is defined as a three-sided figure with three angles, where the sides are line segments. So if we were to take three line segments, connect them together, then the line segments themselves would create angles. By definition, the angles are those continuing rays, but if we cut that ray off and create a line segment, then we can still have an angle formed by those two line segments. If a figure or shape has exactly three sides, it's a triangle. That's it. And remember that the important thing is that the three sides must come together to form those angles. That's why we have a triangle that has angle and measurements of sides. And triangle literally translates to three angles. So let's look at some examples. As long as we have three sides, we can have a triangle, no matter how big. Oops, that should be a straight line. Make sure that the line segments are straight because lines are straight. Or as small. The point is that all these structures are triangles. Oops, well, not that one. Oh, that's a highlighter. Whoops. Oh. Blink. Hopefully you get the idea. Reminder, all triangles have three sides and three angles. Because those are the defining features of a triangle, we can name a triangle based on these features. Triangles are classified by their sides and their angles. Recall that we talked about angle measurements, how if it was between certain amounts, it was an acute. If it was exactly a measurement, it was right. And if it was greater than 90 degrees, it was obtuse. We can do the same thing with a triangle. Because a triangle is a shape, it also has three sides, and we can use the side relationships to determine triangles classification. There are three different ways you can classify a triangle by its sides, because there are three sides. You can either be scalene, isosceles, or equilateral. In the next slide, we'll talk about what each of those mean individually. By the angles, just like in the previous video, we have acute, right, and obtuse. When you have a triangle, you can use two words, one from sides and one from angles, to describe the triangle. So let's talk about the sides first. We have an equilateral, isosceles, and scalene. Scalene triangles are triangles that have all three sides different measurements. So there's no sides congruent, is another way of saying that. In an isosceles triangle, two of the sides are equal or they are congruent. So we say they're either have the same measurement, which means they're equal in measurement, or we can say they're congruent, which means the structure itself is the same. And then finally, equilateral, then, the only other choice is that all three of them are equal to each other, or all three sides are congruent. If we look at the diagram here, we see these little marks. Those little marks indicate congruency. So in an equilateral triangle, if we have lines on all three sides, then we're saying that this side is the same measurement as this side, which is the same measurement as this side, and therefore, by definition, must be an equilateral triangle. Isosceles is a similar, but instead of having three sides equal, there's only two sides that are congruent. And a scalene, of course, has no sides equal. It could be 5, 10, and 15 for my sides, but that would mean it's a scalene triangle. And again, those lines show congruency, which to us, if a structure is congruent, then it has the same measure. Now let's talk about acute, right, and obtuse. Just like in the previous angle video, the definitions of acute, right, and obtuse are the same. The limitation for here is that it is about the triangle itself. So if we have an acute triangle, what that means is that we have three angles. All three angles are acute. In other words, each angle is less than 90 degrees. Now that does not mean that all of them are always equal to each other. There's only one instance where all the angles can be, if they're acute, then they also are all the same measurement. But that's not necessarily the case. You could have a triangle that has an angle measurement of 40 degrees and 80 degrees and then 60 degrees. So then that would still be acute because all three of those angle measurements are still less than 90. In a right triangle has to have one angle measurement exactly 90. And then in obtuse, we can only have one angle that is between 90 and 180 degrees. Please note that in this slide, I forgot to put the degree symbol in this slide. So when you do write degree measurements, make sure you have the little symbol. Let's do a little symbol like here. Whoop. Degrees, degrees, degrees. There we go. Okay, so it's supposed to be 90 degrees. It's hard to write with this pen sometimes. Anyway, let me continue. So notice that in the right and obtuse definition, it says exactly one angle. The other two angles we will find have to be less than 90 degrees for a triangle to be formed. In class, we're going to talk about one of the biggest theorems in triangles. So now here's time to practice. Here is 10 different triangles. What I want you to do is I want you to classify each triangle based on the based on the angles that are provided and its sides. So for example, number 1, we look at the sides. Are there anything that's congruent? And then we check to the angles. Are there any angles that are obtuse or right? In this worksheet, if you have an arcing angle, it is considered obtuse. If you have a square in the angle, it is considered right. And the little lines indicate congruency between two or more sides. Please take a moment to pause the video to attempt and practice. All right, hopefully you paused the video so you could practice. Let's look at the solution. So here you'll see that for the first one you have an obtuse scalene. There's one sweeping arc, that indicates an obtuse angle. And since none of the sides have little lines, little like dashes in them, we're saying that none of the sides are congruent. Therefore, none have the same measurement. By default, then, that must be scalene. In number 2, we have another sweeping angle, which indicates obtuse, but then we have two dashes on two of the sides of the triangle. That means those two sides are equal in measure, and therefore is an isosceles triangle. As you can see, the rest of them are all listed there. Some that are right, some that are scalene. The only one that's, there's two of them that are equilateral, which are 7 and 10. You'll also notice that in those both triangles, they are both acute. And we'll find out what those angle measurements are in class.